They probably like messed up this feather.
Places, everyone.
Places.
Okay, this isn't going to be a conclusive presentation, but it's going to be a presentation.
What does that mean?
It means I'm not going to cover every aspect of special relativity, but I have some resources that might help.
I don't think that's how you use the word conclusive.
Good point.
This isn't conclusive?
Inclusive, or like
Conclusive. What does conclusive mean?
like you draw a
know
definite
what you're
conclusion.
asking.
So like the end is a conclusive end.
Yeah.
Okay, anyways.
Oh.
Time is relative.
Ah.
This is, see, that was really slow because time, I don't know, that was an accident. But the entire like central tenet of relativity, if you will, is that time is relative depending on how fast you're going, and then kind of dips into like how close you are to a big thing, like a black hole. Hashtag interstellar. This is a quote from Albert Einstein for all you non-science people. It's just a fun one because, yeah, pretty girls, Esther. Don't giggle like that. So something we see is like light bouncing between two mirrors, right? It's going the same speed back and forth, so it's bouncing between. But if you're moving the mirrors, if you're going sideways as well, it takes longer, right? It has further to travel. And so that's kind of the concept behind it. So if you have a clock moving at this speed, then it's going to be experiencing time slower, further distance type thing. It's funky, but it's, I don't know. I feel like, yeah, here we go. So the twin paradox is a thought experiment developed by Einstein. And basically, if someone stays on Earth and then their twin goes off and travels at near light speed, time will pass slower for their twin because they're going fast. That's relativity. And so if they go there and back, you can see a bunch of time has passed for this dude, but less time has passed for their twin. So they're still born on the same day, but they're different ages. And like, that's an exact number. Like, if a trip takes 10 years and they travel at light speed, it appears to them as 3.12 years. That's basically all of special relativity. Not all of special relativity. That's time dilation. That's what this phenomenon is called. Time dilates because you're traveling near the speed of light. It does not like the slide. There's a lot going on. Connecting it to history, we have Erwin Freundlich. He went to Crimea to go prove special relativity in 1914. And at that point, it was flawed, like Einstein did it wrong. But luckily, he got captured because World War I happened. Hooray! Einstein is saved. And then later, Sir Arthur, oh wait, I have a picture. There he is. And then later, Sir Arthur Eddington proved it with a different solar eclipse. He went to Africa. And yeah, and that was like, okay, this is actually a real thing. And then jumping all the way to the future, we have LIGO. They detected gravitational waves. Yep, and then we're gonna jump back, okay?
So we jump to the present?
Yes. Yeah, right now, but like not that long ago. And then back in history, we have the Hafeel and Keating. Here's a blurry picture. Basically, they took atomic clocks on airplanes. They had 2 clocks on 2 airplanes, and the airplanes went east and west, and they flew around the world twice. And basically, special relativity predicted that since they were traveling at a speed and were further from the Earth, that the clocks would like be messed up compared to the one that's in DC. And whenever they compared it, it matched with special relativity. So it was just a cool little moment. They used, like passenger airliners, pretty crazy. So, and then Michelson-Morley, I hope you know their name right now. Again, very blurry, but they suspended a marble slab in a pool of mercury for their experiment, their namesake experiment. And basically they were like, okay, if we like match this up with where the sun is coming from, is it gonna change stuff? And it worked out that luminiferous ether, the ether didn't exist, and it was like, okay, maybe relativity is actually true. And then Kennedy Thorndike is just a different flavor of Michelson-Morley. Again, some of these are buzzwords, like Michelson-Morley comes up, it'll get asked about, and then Kennedy-Thorndike is more obscure, but they're just good to know. And then, yeah, that was the real nail in the coffin. I don't know what that is. It's a thing. There's a cat in a box. It's not Schrodinger, I promise.
Why is it purple?
Listen, it's periwinkle. I think we're nearing the end. Okay,
Oh.
application, right? So in chemistry, I have a thing about this, but like electrons are traveling near light speed, and so this determines like some of the properties of metals. This is why gold is yellow and why bronze is, or copper is, brownish. Buzz Lightyear, right? He travels near light speed, and time passes slower for him, so when he comes back, like, all his friends are dead, and he has to save the world. That's that whole thing. Same thing with Interstellar, but there it's more general relativity, because as you get closer to a gravitational field, such as a black hole that's really strong, time also passes slower. So you can either go really fast or get really close to a big thing. That's how you dilate time. And then GPS, if you remember the airplanes flying around, satellites are doing the same thing. So they have to correct for that constantly because special relativity is affecting them. So they have to, change their clocks to match with Earth because they're being messed up. I have some YouTube videos here. I don't, they might play, I hope they don't. That one's goofy. I'm not a great recommend, but it's chemistry and relativity. It's pretty good. And then Kerr's Just Gods or whatever, I can't say it. They have a bunch of really good videos, but this one's really good. And if you're interested in oh my gosh, is the entire future gonna happen already? It's just a fun, quick little YouTube video to watch. And it talks about relativity and tachyons, which go faster than the speed of light, so they go back in time, and they have negative mass or something. I don't know. YouTube videos are your friend because they can explain it way better than me. Oh, and it's gonna try and play them, and we're gonna skip past. The end. Thank you.
Oh my god!
Who's next?
Yo, the .com is crazy.
These dudes.
Wait,
I want to see
Keep
Gage.
yourself safe.